So I'm going to step through the new PSoC 3.1 creator that has the Bluetooth Low Energy support for the PSoC 4 BLE and the PRoC BLE SoC solution. I've already downloaded and installed the Cypress version 3.1. And just go ahead and find it and launch it. The really nice thing I like about the PSoC Creator 3.1 is that a lot of information is embedded, and a lot of, including data sheets and actually detailed information on the stack. They have component data sheets embedded in the Creator, which you can actually look up and do additional reading on. So I'll just go ahead and register later. This is your typical PSoC Creator startup page. I'm just going to go ahead and actually start a new project. Let's just go ahead and just do a blank. Actually, let's start with a template with the PSoC 4100 or PSoC 4. So there's a 4100, 4200 with BL. BL stands for Bluetooth Low Energy. Example projects here. I know the evaluation kit comes with the 4200. Let me just do a simple BLE Find Me application, which basically just uses the radio to do alert notification. This is an example that we have here. It actually has a lot of good information. It tells you about the dev board and what the different interfaces are for the LED, their purpose, and so forth. But the important thing here is in the Bluetooth stack itself, and using the stack is very simple to set your specific configurations and parameters. Right here you see the block diagram for the Bluetooth Low Energy stack. You'll notice here on the left there's not any code generated yet, which includes the PWM and the BLE stack and the switches and LEDs as well. But we'll get into that in a minute. But let's go ahead and left-click the BLE component. This is where it saves a lot of time when configuring the Bluetooth stack for your specific needs of your application. So it starts off with General, which in the General tab, what we have here, you can select the specific profiles. Since I picked the example Find Me app, it defaulted to the configuration for Find Me. But however, you can choose the different profiles here that are supported by the Bluetooth SIG and by Cypress. Notice that there is also a custom profile. This is where if you need to send custom data and create your own profile service, your 128-bit profile service and your 128-bit UUID characteristics. But just for this example, we're going to stick with Find Me. You could also choose the profile role. Now, profile role within Bluetooth Low Energy, it's the information which device is going to be the server and which device is going to be the client. Since in this particular profile, the device is going to be the GAT server, so we want information that's off of this device. Typically, maybe an iPad or an iPhone or an Android phone would be a GAT client to gain access to information that's on this device. We could actually set the role as well. GAP role is there's a peripheral mode and a central. And in this particular case, since it's a peripheral to an iPad or an Android phone or an iPhone, it's set to a peripheral. But here you can see the different choices to set your device to be a central mode or peripheral and central, which is part of the new 4.1 spec of being able to switch roles during the application. If we actually go into the profile details, this is just list the details of the specific profile. So we have generic access information. We have with the device name. So the device name here is Find Me Target. The appearance. A lot of this information is based on information that's populated in the general tab and the gap settings and built in. So you can't really edit information here, but you can in the gap settings. So within the gap settings, in general, I could actually set the device name and say Alan's Find Me. Or in the advertisement settings, you can also define the discoverability mode. So we have a general mode, which is advertising and connectable, non-discoverable where you're not connectable, and then limited and so forth. You could also choose your advertising type. Again, this is kind of the discovery mode above. And then your filter policy, if you're the central device, if you're creating a whitelist, or a peripheral device, a whitelist of devices you want to connect to or devices to connect to you. Channel maps, you can choose all channels, which is preferable and recommended when you're in advertising, or you could limit it to a certain channel. And then your actual intervals. So you could actually define your advertisement intervals here, and this is really nice. To use this type of system, graphic user interface, instead of embedding all of this information in the code. In the advertisement packet, we can see that we're advertising the service UUID for immediate alert service, but then you could also add specific data into this advertisement packet. Now, depending on information, we could actually add specific data as well if we were using a custom GATT profile. But we also want to list our local name in the advertisement packet. Let's do a complete name. But as you populate the advertisement packet here with your selections or with your particular data, all of these are exposed. You actually get a warning that the maximum length of the packet, which is 31 bytes according to the Bluetooth spec, that you've exceeded that amount of information. So this is actually a good tool to let you know that, hey, every advertisement packet you only have 31 bytes, and the information that you want to send across exceeds that. So it actually does a check for you and does some housekeeping for that information. So I'm just going to leave the immediate service data off and just leave my local name on. So this is the information that's going to be advertised in the advertisement packet. Scan responses. This is, again, another type of, if you are inquired, the type of information in a scan response packet, same as the advertisement packet. And then security. So we can set security, mode 1, mode 2. The nice thing is that you can actually, if you don't know what these modes are, you can click on datasheet. And the datasheet for the BLE stack would be pulled up. And most of the information that you will have questions for within the BLE stack will be within this datasheet. Let me go and close this out. But I don't want to, let's say I don't want to do security, pairing method, I just want to use JustWorks. There's the old passkey entry, out-of-band pairing, or JustWorks, and the bonding, and the encryption key size. So this portion of the Bluetooth Low Energy stack within the PSoC Creator is very helpful. You can set all of your parameters, your settings, within this menu without having to touch any code. But let's just go ahead, and you notice here no code has been generated. Let's go ahead and apply and hit OK. And I will generate the application. So while it's generating the application, all of the APIs, header files, and everything you need for the Bluetooth Low Energy is automatically created here. So you can see all the BLE header files, C files, and stacks, and services. Again, everything's already been set based on the parameters that you've set in here. Now you can add more code to complete this example, to link a certain behavior and so forth, but that's a nice thing. So it generates most of the code that you need, the specific files, in particular with Bluetooth Low Energy, very easily. So let me just go ahead and close this workspace. There's a couple example projects that are already embedded within the PSoC created for Bluetooth Low Energy. So I'm just going to go ahead and filter by PSoC 4 with Bluetooth Low Energy support. And here are all the example profiles or example projects that is already existing for within Creator. Again, all of these are based on PSoC 4200 with Bluetooth Low Energy support. Some of them will specifically have BLE as already integrated, but then this is the family of chipsets. So I'm going to compile, let's say, the blood pressure. No, let's do the heart rate sensor and create the workspace. So I'm going to choose a folder I created. Oops, chose a folder I created already for my Cypress projects. So, oh, and here's another nice thing. If you're opening an example project, you can see that there's a data sheet for every example project. So this is a data sheet that's embedded within PSoC Creator about the example application. So this is the Bluetooth Low Energy heart rate sensor example project. It talks about the different services, its general descriptions, the IOs, and the information that's specifically for the Cypress kit. It shows you the different block diagrams within that sensor example project, and it talks about the stack and the GAT settings and advertisements and so forth. So this is a really nice data sheet on the example project that I chose. So I'm going ahead and this is already a finished example. This example is using LEDs to determine the disconnect and advertisement mode, a switch to do wake up the device for deep sleep, UART for debugging, but the most of the information is gonna be using the Bluetooth Low Energy stack, and there's some source code in here already that determines what the peripherals are, or the heart rate and sensor. So within the heart rate sensor profile, there are specific attributes such as including battery service and the device information, and attributes such as the location of the heart rate sensor. So within the heart rate sensor itself, there's some attributes that we can look up in here. Heart rate measurement. We have the different specific characteristics of the heart rate measurement. So we have their R&R interval bit, heart rate value, sensor contact. So again, a lot of this information is within the BLE configuration. Another parameter is the sensor location. So right now we have the body location is in the wrist, but let's say I want to do a chest sensor. I'll click apply here. And you know what, I'll go back to wrist. And I clicked everything. So I will just hit the generate application, or you can just hit program. It'll also compile the application. I don't have my board plugged in yet, but so let me just go ahead and compile this application. And here we go. So here is the generated source code. with the profiles, all the headers and C files specifically for the heart rate sensor profile and using the Bluetooth Low Energy stack. So let me program my board. And then I will use the Cypress CySmart iOS application to demonstrate this heart rate profile. Once it finishes, I'm almost done. And I'll actually use a different iOS app that specifically has a heart rate sensor to show that it's not just specifically to Cypress. Any heart rate sensor application on an iPad or Android should be able to work with Cypress's example. So I've just compiled and downloaded the Bluetooth heart rate sensor for the PSoC creator in 3.1. The target board here is the Bluetooth Low Energy Cypress evaluation board with the PSoC 4 module. So what I'm going to do here is launch the Cypress CySmart application, and I'm just going to hit reset here because the module entered a low power state. But as the program runs, you can see the LED blinking that it's in advertisement mode, and from the application here you can see that it's here it's found the heart rate sensor. If I zoom in, you can closely see what the application is doing. So I will select it. Now it's asking me to pair. I know it's a little bit hard to see. Yes, I want to pair it because we have encryption and authentication enabled here. So after we pair it with the device, we can then connect to it. And then we have the heart rate profile from the CySmart application. And from here we could see the location right here. It's the location of the heart rate is the wrist. We can see the beats per minute. This is a gradually increase in heart rate. It's an automatically generated number heart rate within the application, since we're not really interfacing to any sensor that's on the board. We can display a graph here in the low part. We can show a graph of the heart rate. As we see here, it's going up and dropping down, up and dropping down. But to prove that this heart rate sensor profile is interoperable and it's based on the Bluetooth spec, I will then actually launch another application, one of my favorite applications for heart rate profile is based on Bluefire EKG. This is an application that was developed about 4 or 5 years ago for CES on promoting Bluetooth Low Energy and the heart rate sensor. So I'll show you here that there's no heart rate sensor connected, so I'll connect and search for one. So this app's a little old. It does go through a 10 seconds on discovering all of the devices that are within range. And it found the heart rate sensor, shows the signal strength and the UDID. So I'm going to connect to it. And it has also the same location connected. And you can see the beats per minute as they increase. So after you've had your heart attack, it goes back down and starts over again. So this is just an example of a running after compiling the example heart rate sensor and programming it on the Cypress BLE evaluation board and using iPad apps to verify its functionality.